Okay. Well, since we missed a couple classes last week, we're going to go ahead and just assume our JSON thing is done. I have a third-party thing we can use anyways. I don't want to waste any more time on that. So we'll just pretend like we finished it. So over the weekend, you had a homework assignment for a paper to explore blockchain technology as it applies to other things, right? So up to this point, we've kind of thought about the blockchain as being the means to an end for validating Bitcoin transactions and birthing new Bitcoins, birthing new cryptocurrencies. Now, there's been some, and I think you actually messaged me the other day, right? That was you?
Yeah.
About, that you kind of believe in the blockchain side of things, but less so in the currency side of things. And that's fair. So, we kind of have to see where things fall on that side of the coin, I guess. So what I wanted you to explore with the paper is the blockchain technology in general and how it could be applied to other problems outside of the problems originally designed. Anybody come across anything interesting?
I saw someone doing DNS stuff. Like
Okay.
They had .bit domains where
Oh.
it was like keeping it, so like the government doesn't take down your website or something like that.
Okay. So historically, the domain name service, it supports a bunch of like .coms, .net, things like that, domains, .org. And all of those are kind of validated by a central council type place. But the government could take your website down or something like that. So now there is a secondary, I'm not sure exactly how it works, but my guess is what they've done is they've inserted a DNS server that takes any .bit, let's just use that as the domain, and redirects it to a validation that is being validated by the blockchain for whether or not it exists or not.
I mean, as far as I know, from what I was like reading about it, it's like everybody it's Namecoin, so then you use Namecoin, which is a fork of Bitcoin.
Okay.
They did say that. And you pay for your bit domain. And I guess maybe like everybody who's on the network, it's kind of how like the blockchain validates, everybody who is in this like Namecoin network validates each other. I don't know.
Okay, so Namecoin, the currency, exists for the sole purpose of purchasing .bit domains. And the blockchain that's used for validating and creating Namecoins, since the transactions are happening on that, using that blockchain dictates what .bits exist,
I suppose, yeah.
what domains exist.
That's how it works.
Okay, and the idea being that there's no central authority that can go and take down a dot whatever. Okay, got it. So DNS for .bit domains. What else? Go ahead.
I found one. I'm pretty sure it was like with the blockchain bit message,
Okay.
and it sends like the incoming and outgoing messages are like encrypted, and recipients like if it's designed to like if that message is for them, then they're able to decode it. But if it's not for them, then it moves on.
Okay.
All like the messages have like their own public key and like thrown into a pool and like mixes them all around, so like you can't trace where it's sent from.
Okay, so it's taking existing encryption technology, stuff that already exists, and is using the blockchain as the transport layer for sending messages between unique addresses for the recipients. And only the recipient at that unique address can then decode the message, something like that. I wonder why it would even need to be encrypted. Well, actually, I just answered my own question. Tell me, why does it need to be encrypted? It's an extremely good reason why it would need to be encrypted.
It needs to be encrypted so that like other people can't read the message.
Because the blockchain's public, right? Otherwise, you can just watch their whole conversation on there.
Who's this being sent to? I don't know, but I can read what it says.
Yeah, that's it. Yeah, you don't know who it was sent to, but you know what it says. I'm trying to decide whether that's actually a good idea. If we think about it from a perspective now, let's say somebody wants to, let's say you're sending encrypted emails or encrypted messages to somebody through one of our instant messaging programs, somebody would have to sit there and sniff the network to get the packets and then take apart the packets and decrypt the messages then. So there's some extra work as opposed to having this constant buffet of encrypted blockchain. You have the place to go to, like messages are here. But then again, I guess the idea would be that the security is in the recipients, not the messages themselves, where we're going to make it inconvenient to read the messages by encrypting the messages, but the recipients, if we don't know who the message came from or who the message is going to, the message might be somewhat useless.
Yeah, that's a criminal. I see this
It's a criminal.
being a good opportunity. I get my drug cartels and stuff all in place.
Yeah, and there would actually be a point, just because you don't know the name of the person that something went to.
Yeah.
Couldn't we actually look through a blockchain and look at all the messages that went to a specific unique address? Alternatively, what we could do is you could create for each message a unique recipient address. Remember, when we were working with Coinbase, Coinbase had one of their APIs allowed us to request a wallet address. So we could do that on a per message basis, so we would no longer be able to see 500 messages going to this one address. Every single message went to a different address that one person's wallet owned, something like that. So from a criminal's perspective, we wouldn't necessarily be able to put together those messages. We wouldn't see, here's the 500 encrypted messages all going to this one recipient. Let's try to decrypt them and put together a story or something. Do you have something? Oh, you're just waving.
Yeah.
Oh. So, all right. So messaging. Is that messaging or massaging? Did I spell it right?
That's messaging.
Okay. Cool. Anybody have massaging? All right. What's another application? Or did everybody write their paper on those two? Go ahead.
I found one that was on proof of existence, so kind of like a notary type thing.
Okay.
What it is you take whatever document that you have and you hash it, and then you there's a function in the blockchain code or whatever that allows you to insert a small amount of data into the blockchain without actually making a transaction and sending money.
Oh, okay. I wasn't aware of that.
And so what you do is you just insert your hash, and then because you have to have the document in order to have the hash, the document is proven to have existed at that point.
Okay.
So then down the road, if someone's like, oh, if it's like a will or something, you can say, oh, this was made I had this made at this time.
Gotcha.
And you don't need a notary or.
Well, it really should be better than a notary.
Yeah.
Notary is only trustworthy as much as you trust the notary.
Yeah, exactly. It doesn't need the element of trust because
this is the
it's
public
proven.
record. Yep. Okay. That's interesting. All right. Anything else?
Basically the same idea of the technology that he was looking at. I was looking about BitNation,
Okay.
blockchain ID, and it works with like a proof of existence base that they get the hash of the hashes, and
Now, is it for documents or for like individual IDs?
individual IDs.
Okay.
But actually they have ones that create documents too, like for marriage things, because it's like a governance for if you don't want to like be a citizen of the United States anymore, you don't pertain to this new hippie thing.
Okay.
So you can like just be part of this, and they're gonna create all of your documents. And similar to this, last week I created a technology that based on Bitcoins, that each government can use it for create passport using the blockchain too. So
Okay.
it's kind of good because you cannot falsificate this. You cannot have the falsification of these documents anymore.
Yep.
Because it's almost impossible.
Well, that's kind of interesting. So instead of so let's think that through. So instead of having a physical passport, you would have your unique identifier, which says that you have this passport or something like this,
Yeah.
and you'd have to like maybe log into a system proving that you are that person.
Yeah.
So more than just having a document that might fool somebody, now you have to have a a two-tier authentication type thing where you can log in and show them.
Yeah, apparently for you create this passport, you have like to go get the hash of the hash that I forgot the name. You have to write down a paper, you have to take a pictures and say that this picture is gonna have like a host that's gonna sign this with you.
Yep.
And they're gonna create a signature and then after that gonna use the PGP technology and create a unique address that you have to send and actually make this like official.
Mm-hmm.
It's pretty cool.
Okay, that sounds interesting. So really kind of along these lines, but I'm just going to actually write passports. Okay. What else? What?
I think along the same lines, it could just be a way to identify yourself as a person. So, we all have social security numbers, but this could be a global thing, a global database of every single person that's ever there.
Not married to a central authority.
Right, and this way you can kind of just make it a universal way to connect to different ways of doing things in general. I mean, you can, give your information to a store and that will be connected to all of your accounts, all of your information, but you can't access it unless you have your own ID and your own maybe password to get into that. And it's very secure in that way, so there's no way you can get into it and people can steal stuff. So maybe it should be something you can do to just have a universal database of information to...
Is that really better, though, than taking each person and tattooing a serial number on them? I'm a fan of tattooing a QR code across their entire face. So you scan it.
Wait. Okay, you close your eyes and squint a little.
That's right. So we wouldn't have to deal with all these technologies with facial recognition. All those things would just scan the facial QR code.
Just QR code.
No, I mean they're
They're
on the whole face. That way you couldn't have a, like a hat, a brim or something.
The invisible ink tattoo. Yeah, so that it doesn't show up.
Makes sense.
Use that glow-in-the-dark spray paint.
Okay, so anybody else have something that differentiated from these quite a bit? Go ahead.
Yeah, I was looking into like MMOs and using Bitcoin, like the blockchain for same purpose as Bitcoin uses it as transactions without authentication though. So, or even making a whole new part of an MMO where mining becomes a.
Well, how does this connect to an MMO? I guess is what I'm trying to figure out.
You could instead of having the currency be all just based off of
Just random in-game currency, gold.
yeah,
Okay.
you can actually make it into a Bitcoin currency. Just pretty much take the idea of Bitcoin and put it into an online gaming part. And then actually have part of the game where instead of mining golds, you're actually mining the transactions.
Well, now I can sort of see that working if you want to try to create an economy. And actually, I've thought about this for a while with games like World of Warcraft, because and actually any new game that comes out, there's always an economy for like gold or whatever in the game, and there's usually companies that do gold farming. They sell you gold or sell you whatever the currency is for the game. So the very first thing you'd have to do is you'd have to have the monsters in the game stop dropping coin. They could drop items, but they would have to stop dropping coin. There has to be an economy of money in there that gets created. There's only so much money in the, let's just use World of Warcraft as an example, so much money in the World of Warcraft economy at a point in time. And that money is dictated by, we can have like a mining type thing. Maybe when a player plays, that's a action of mining or something, and that they can earn coins that way, or coins are born that way, or something like that. That would keep third-party people from being able to create to create coins without actually playing the game or something like that. Could be interesting. I guess the question is whether or not that's a big enough problem to be worth it, but that's not necessarily.
I'm sure Blizzard would say it's a big problem.
Well, I guess it depends. Does Blizzard actually sell gold yet?
No, they don't. But
Because they sell everything else now, don't they? You can buy a max level character, and
Everything but that.
yeah, I'm surprised you can't just buy gold. Okay.
It's like our,
You don't need to buy gold when you can buy everything else.
Yeah, but you need to pay for like
I mean, there's
repairs
some
and stuff.
you can't,
I'm sure that one of the
They
reasons
don't
why
sell
they
repair.
don't like do that is because
So they
they
don't sell everything.
their competition would be within their game.
but they're not.
They would have all these big name companies
Yeah,
doing the mining. Stuff like that.
Our dungeon crawler from last year.
that's right. That's where our coins are going to come from.
Mine Bitcoin. From
Mine Bitcoin from that. Okay. Anybody else have anything interesting? I think the MMO money thing was kind of stupid.
It came from me.
Yeah, you tried. You tried.
Is that what you wrote your thing about?
Yeah.
Did you make more sense than that?
No.
No.
Uh,
I mean, it's actually not a horrible, horrible, stupid idea. I just wonder how applicable it is. But certainly it could be I mean, it makes sense. I'm just not sure somebody would do it.
when I was searching for a topic, I did see one that was like a trading card game, except you could trade the cards with whatever currency, whatever cryptocurrency they were using, and then I moved on.
And then I moved on.
Diablo has the real money though. If you remember that.
You can buy real money.
No,
You
no,
can buy
you
in-game
buy
money with real
stuff.
money.
No,
No, they
you can buy.
closed that.
Oh, that's right. That's right. You could buy in-game stuff, not currency, but in-game equipment with real money.
Yeah, and you can sell it too for real money.
They closed that though.
But yeah, they closed
Yeah. Why did that fail?
Because of
Is that the whole pay to win thing?
well, no, it's because people were just going and doing pretty much what you were saying with gold farming. They were doing item farming, and then ended up going to the what do they call it, the big house or something.
Whatever, the auction house thing
Yeah,
for real
auction
money.
house thing, yeah, and they would just sell the items and get money from it, and they were just doing that and farming it out, and it failed because as soon as something would go on the auction house, it would be like huge prices on the auction house.
And then it drove the prices down to nothing
Yeah.
because there was so much of it on there.
And people were using like double characters to buy the item and then convert it to real money through the auction house. So
I'm not sure how that would have worked because they would have had to, the source of the money would have had to been from a real person.
well, they,
Yeah, I don't know, but
it was just a huge failure.
okay. So let's talk some about this idea for voting. I assume none of you ran into this as being something that's already being done, right? I looked into it quite a bit, so I don't think anybody's doing voting with blockchain at this point. Okay, because that would be upsetting if you.
I saw something that somebody had made, but not that's being used. It's called like Bit Congress.
Bit Congress.
Yeah,
And how did that work?
I don't know.
Okay.
Well, because it wasn't being used, so I didn't. I mean, I looked at it, but I didn't like look at it that in depth.
I gotcha. Well, so let's talk about voting in general. So voting in general has multiple things to it, right? So we might say that each person gets one vote. That's one goal of voting, right? We're probably not necessarily meeting that goal right now. I mean, when we're talking about small little things like voting for class president or something like that, chances are we're adhering to it. But important votes, presidential votes, things like that. Every single election, there's stuff about how you have dead people voting and stuff like that, and it's a big kind of nightmare. It's amazing in today's world that we can't accurately vote.
It needs a QR code on their face, so you can.
Yeah, we could just scan your face.
Yeah.
Well, then you have people stealing other people's faces.
Oh, and cut off.
It's always cheats on Huawei market.
Just kind of duct taped on. Okay, so each person should only get one vote. Counting votes needs to be 100% accurate. That's also another issue we have, right? Some of you, well, what year was it? It was 2000. Yeah, how many of you remember that? That was your state. Yeah, it was your state. Yeah, so in the year 2000, when you had Al Gore, George W. Bush, that big election, there was a bunch of discrepancy over voting. We used 20 different technologies for voting, and there was the whole hanging Chad thing, and dimple Chads, and old people couldn't vote properly, and all sorts of different stuff. So there really becomes a problem with being confident in a vote count. Accurate enough? Now, one problem we're not going to solve here with this is the different ways that we can vote. For instance, for the president of the United States, we use this electoral college thing, right? So for instance, in Illinois, and this is, kind of an issue I maybe see with that, but, I'm one person. You look at the state of Illinois, and most of Illinois is Republican in terms of land mass. But Illinois almost always votes Democrat.
Oh yeah.
In the electoral college because of Chicago. It's population density type thing. So, I don't know. It seems to me like if you could, since it's the president of the United States, if you could legitimately count 100% of the votes, shouldn't it just be every vote counts as one vote? I'm thinking. But who knows? I mean, there's pros and cons both ways. But the point is that's not a problem we're going to solve. We're solving the problem of counting the votes that come in the collection it comes in. So if we're counting votes at the state of Illinois level, or counting votes at the United States level, or counting votes at the Concordia University class president level, whatever it is. Do we have a class president? Does that exist here?
There's the student government.
Student government, yeah. That's their president of that. So that would be like the class president, right? All right.
Yeah.
Whatever. Okay, so one of our goals is to count votes with 100% accuracy. We want to have confidence that our vote counting works. And we don't really have that confidence with the current methods for voting. So each person gets one vote. We need to count them accurately. All right? Now, how can the blockchain... Well, first of all, is there any other goals of voting that you see?
The speed of counting.
Yeah, I mean, I suppose. Counting has to be relatively quick. I think if we're going to use the blockchain, it's going to be faster than human beings can count it now, or especially when they have to go back and recount, because we're relying on many different technologies that currently count. And as long as we decide we trust that count, we don't recount by hand. But if we don't trust that count, then we do recount by hand. And we even look at this from a small situation. How many of you have ever had a stack of something that you counted, and you counted it 3 times in a row and came up with 3 different counts? You're off by 1 or 2 or something like that, but if you get a really close election, that could be a big deal, right? I mean, in that particular election in 2000, in the final count, I think Al Gore had more total votes. Just the electoral college votes was higher for George W. Bush. So that would be an example of almost always the winner of the presidential election is also the person who gets the most popular vote as well. So it's kind of one and the same. But that particular election was, I don't think it was the only time it's ever happened, but one of the few times it's happened where the person who won the election did not get the most number of votes. Just happened to be won the right states. Any other goals? Go ahead.
Kind of with the time zone change could be a factor.
Time zone change?
Yeah, so the fact that all of the votes are coming in at different times. Because when in California, vote later than say Florida.
Okay, so maybe the type thing where we have some sort of time stamp with the vote to make sure that all votes are in by so using a global time system with the right kind of shift. So if we're going to have the polls open in California at a certain time, we're not going to count votes that come in after that period of time or something like that. Okay, fair enough. So maybe we could say a goal is official start and end time for voting. Fair enough. Okay. So one thing I want to put out here. Somebody have something? A couple of problems with voting. Then we'll jump back to this one. These are problems over and above what we've already discussed. So one issue with voting is being able to dictate who is allowed to vote and who is not. Okay, so that becomes kind of a different problem than this idea of each person is allowed to vote once. So for instance, still using presidential election as an example, how old do you have to be to legally vote in a presidential election? 18. So that means everybody who's younger than 18 does not have the right to vote. Correct? So we can't have those people going to the polls and having a vote that counts. So one issue that we're going to have to deal with is how do we validate people who are allowed to vote? And I'm not sure that's something that can be solved with the blockchain. If it is, that would be a really cool thing. We might have two different solutions here, so something to consider. But at some point we need to have access.
Well, I mean, the first way I see to solve something like that would be to have your identifier in the blockchain be assigned to you at birth, and then you just have, oh, you are now, you have to be such and such age. So until your identifier passes that age, it doesn't count.
Okay. So really, there's two separate systems here. Almost the one system for am I allowed to vote becomes a voter registration thing at birth, and that is kind of our social security number handed out by the blockchain.
The issue is people can't be added later.
Well, if you preceded the blockchain, you could. If you decide there was a one-time, we're going to build the blockchain as if it has been in existence forever, and you preceded it and then started the blockchain from that point forward, it's possible you can maybe make this work.
But then if people become a citizen,
then you don't have their age.
you don't have their age.
Yeah.
So that probably won't work.
So there's a point of failure as they enter into the blockchain. How do you?
You have to have been a citizen for.
Yeah. Okay. Yep.
Or make their assigner a hash value taken from their license or identification card.
Well, but I don't think you have to have. Well, actually, you do have to have an ID.
Yeah, you have to have an ID or a birth certificate, but you can make that a new part of voting. Like, just be like, you have to have your ID before you can vote. I mean, it's kind of pretty standard, I guess, but yeah, that would be a.
Who's allowed to vote?
I was gonna point that out.
Oh. Well, so let's build onto this. Who is allowed to vote? How do we validate that someone is allowed to vote? And some interesting things that are happening in the world even today, and this is on a state-by-state basis. Some states are moving away from requiring that voters even have to show an ID. I'm trying to think of which state. There's at least a couple of states that have done this. And the argument is that some old people find it difficult to keep track of their IDs and stuff like that. So you can literally show up to the polls and just say who you are and not have to prove that you are that person.
Well, I guess.
And this flies. I mean, it's really kind of embarrassing how voting works today, but
It should all go back to scanning the face.
scan the face. Okay, so these are two problems that exist that we may not be able to solve. And really, that's not a voting problem, that's a systems problem. You know, from our perspective, the problem of collecting votes and accurately counting votes is the problem we're trying to solve. There's a secondary systems problem of making sure that people who are voting are allowed to vote.
There's
Okay.
actually a lot of states that don't require photo ID.
Yeah, isn't that just completely ridiculous?
And the ones that do have it are like, it's like recent within the last couple of years where it's been implemented as voter ID, needing a photo ID.
Okay, so let's bounce back here for a second. So how might we use, if we think about the problem that we're trying to solve, collect votes, accurately count votes? That's the problem we're trying to solve. So here we'll actually start another slide. Initially, that's the problem we're trying to solve. Those two steps. Collect them, accurately count them. How might we apply the blockchain to that problem? Any suggestions? Go ahead.
You assign one coin as a voting token, I guess.
Okay.
And the transaction would be the act of voting. And you have, like we said before, you have two wallets that.
And we'll use this as a simple case. We just have two candidates.
Yeah.
For our example, two candidates.
You have two wallets that are receiving, and then as they're validated through mining, which of course the difficulty and stuff will be way down because we don't want time factor. But as they're validated, you get an overall count from validation, and that would make sure that every vote was counted overall, and then you could even go farther and validate each wallet's transaction history, and then you would get those counts.
Okay, well, something you said there is that you want to keep the difficulty down because you don't want validation to take too long,
Well, yeah.
right? But so going off on a related tangent, what would it take to keep the difficulty of that network down? So let's just call them vote coins.
Put it into the system at start. Are we talking about like using the existing blockchain?
Well, no, a blockchain.
Okay.
A blockchain could be anything. It
Yeah.
could be associated with any cryptocurrency.
Okay, then you would just write it into the code of the cryptocurrency to not have a change of difficulty.
Okay. Why?
Because the government would be the only, or whoever's doing the voting calculation would be the only one mining it. It wouldn't be.
Doesn't that actually become a problem? Then we have the 51% problem. That if you only have one group of people mining it, now they can rewrite the blockchain and change the vote. So we would really be better off leveraging an existing currency like a Bitcoin, where already has a bunch of people mining it. Not one interested party, but a bunch of people. And having votes happen, using fractions of a fraction of a fraction of a Bitcoin. Bitcoins go out to 9 digits. So 0.00000001, let's just assume that's 9. I don't know if I say quite enough, but whatever. That's called a Satoshi, the smallest denomination of a Bitcoin. Maybe that's one vote. It's a Satoshi. Okay? So now that's going to go to an account, a wallet. So if we're doing this for two candidates, we have wallet for candidate A, wallet for candidate B. Every vote is going to be 1 Satoshi big. Right? Okay? And they're going to go to that. So it's going to require real Bitcoins to make these votes. Correct? Real live Bitcoins to make the votes. And they'll go to this account. Now, we could say, maybe at the end, the current balance of the account, whichever those two accounts has the higher balance wins, right? Well, we have an issue. That issue is does anything keep... So let's say there's the voting authority at sending this to this account. But now, let's just say that Amish wants to skew the vote. So he runs out and puts 1 Bitcoin to that address without going through any voting place. Just puts 1 Bitcoin, sends it to that address. So now that 1, if we take that 1 divided by is that a million? It's a billion? It is. So if he puts 1 Bitcoin into it, he just represented 1 billion votes. That might,
That's good.
in this presidential election, because we don't have 1 billion people in the United States. So
Well, and they solved
you might want to go with less than 1 Bitcoin because otherwise it might look fishy.
Maybe.
Go with like, I don't know, 0.6 Bitcoins or no, not even that. No, you got 0.06. Yeah.
So they solved the problem.
What's
Just
this?
make it 1 Bitcoin for each vote instead. I mean,
Well,
I
if you
don't
do
know.
1 Bitcoin for each vote, it doesn't solve the problem. If you do 1 Bitcoin for each vote, first of all, now whoever's starting off the initial vote wallet needs to put a lot more money into it in order to support it. Okay, where if we have a population of 500,000, I'm sorry, 500 million. I think it's less than that, but that's 5 million. 500 million, 50 million, 500 million. Whatever number that is. That's the number of Bitcoins we'd need. Some fraction of 1 Bitcoin, something like that to handle all the votes. But the issue we're going to run into here, so having it in bigger denominations doesn't solve the problem. The issue we're going to run into here is nothing keeps, if I'm voting appropriately and I'm sending my 0.0000001 Bitcoins to the person I'm voting for, nothing keeps a secondary person from voting inappropriately and sending Bitcoins to that same wallet. And one thing we don't want to do is we don't want the security of an election to be based on the secrecy of the wallet address, right? I mean, we can't have that. Wallet addresses are considered to be public knowledge. So we can't just say, oh, we're going to keep it secret. We're going to keep it secret. So how do we make sure? Well, first of all, we cannot make sure that all payments come from only the source wallet. We know that anybody if we're going to leverage the Bitcoin network, we know that anybody can send payments to the destination wallet, to that vote wallet. We need to be able to accurately count those payments as being payments made from the source, the correct source wallet, which, maybe there's the government source wallet, for those elections, or if it's a Concordia election, the Concordia source wallet that gets pre-funded with stuff. Go ahead.
And it's an easy fix because you just validate the transactions that come from just the source wallet to the other wallets.
But you don't have control over the validation.
Well, I mean, you would there would have to be some way that you would be able to see, okay, let's just count all the ones that come from the source wallets to these
Okay.
wallets.
So don't rely on the final balance, but
Yeah.
instead let's look at the blockchain and count only votes that came. We're going to come up with our own total for this, and that total is going to be based on the number of votes that came from the source wallet. Okay, so that is if my wallet is the source wallet. So let's say I'm the government. Okay, for this election, and my wallet's the source wallet. We're going to count all. We're going to count all transactions that came from my wallet, not that came from secondary wallets like his. Well, now we have a problem. That is, I have to give people access to make transactions from my wallet. We have a third party issue here where we're going to have to trust somebody to set up a system that allows you to walk up to the voting booth. Okay, you're going to walk up to the voting booth, and the screen's going to get presented to you, and you're going to click the button, I'm voting for this person. Boom, are you sure? Yes. And at that point, behind the scenes, a transaction is created where 1 Satoshi gets sent to the appropriate destination wallet from this one source wallet. Okay, so
So you just use what we designed with the Java app, where we were buying and sending
Mhm.
Bitcoins. You could use that same thing, just make it look awesome with the voting
Okay.
side. And have that on the machines for voting, just running that on the machines, and it would fix that.
okay, but by doing that, have we created a situation where there could be something to hurt the accuracy of the vote? We're trusting somebody to build that machine, the voting machine. Okay, so the person who builds the voting machine is going to put in destination address X and source wallet address Y. That's going to be hard coded into this machine. Well, do you have destination address A or B for your two candidates, whichever one you chose? Does it go to this destination or does it go to this destination? Okay, but the source wallet is always going to be the same wallet. A pool of coins, right? And one fraction of a coin per registered voter. So in the end, if you have 100% voter turnout, your wallet should be 0. The balance of the source wallet should be 0 if you have 100% voter turnout, right? That's if you funded it with enough. As we go farther down the rabbit hole here, we'll see that we maybe don't even have to fund it with that much, because we could just send stuff right back. Once it hits the destination, we can send it right back, because since we're going to be reading from the blockchain anyways, not relying on the final balance in a wallet, to validate it, doesn't matter, if the same coin was spent multiple times. We're just going to be counting how many were spent. But in any case, we're relying on that one central authority, somebody, to build these machines, and hope that they all come from one address. Is that a problem?
Right now you're getting into a moral question.
Isn't the whole thing a moral question? I mean, isn't the problem with voting today really is a moral question?
Well, from
We have the technology to accurately vote today, but for some reason we just don't. And that's because there's corruption and things like that in the system. Does this bypass that? I'm not sure this is any better.
I think from a computer science standpoint, if you had a program made to do it, and the guy's making the machines, but all he's running is like a Java virtual machine on there, say that, and the government has made the app and bring it in and put it on the machines, I don't think that there's either a small chance or any chance of it being corrupted.
Well, let's split this into two separate problems. Does using the blockchain, just that part, to count votes, does it make a transparent record of votes? We don't have to rely on the government counting those votes. Any citizen can go out there and manually, if they chose, look at the blockchain and count the votes themselves. We're not reliant on the news networks to tell us this was the vote count, right? So blockchain right off the bat in terms of counting becomes beneficial in this, right? We have a completely public record of votes that were cast. We haven't solved the first part of the problem, where we want to make sure that only one person gets to vote, that only the people who are supposed to vote get to vote, and they can only vote one time, and all this other stuff, and we haven't solved that yet. But from a counting perspective, blockchain solves this problem because it's public. It's a public record. Literally every single citizen, if they chose, can go and validate the count. And every single time it should come up with the same number. What you'd probably have is 100 different websites grow out of this, where each one would write their own live count of the election, right? That shows the current, the current thing going, and all they're doing is they're parsing and interpreting the current blockchain, the current public blockchain. So, maybe people, maybe they find a way to monetize it or something like that. Maybe there's gambling on the elections, or whatever. There might be whole other economies that grow out of that. but at least from a public record perspective, we're going to be able to vote with accuracy from a count for counting. Okay? So do we feel good that the blockchain can solve that problem? Seems like the blockchain would be very good for that problem because of its decentralized nature. I mean, there's no way for anybody to corrupt the vote from a counting side of things. So we just reduce the amount of, the number of ways somebody can corrupt a vote. Now they're going to have to approach, they want to fix a vote, they're going to have to approach it from the time of the vote perspective. Make sense? Okay? So if we're going that route, let's look at that side of it again. How do we make sure, how do we secure the votes themselves? I don't even want to try to solve the problem of who's allowed to vote and stuff like that. We're just going to assume everybody who casts a vote is allowed to vote for the starting point. But we want to make sure that votes are trustworthy votes. That the vote came from A, the right source, and B, went to the right destination. Well, one way we can protect it is we can say, well, each vote is 1 Satoshi bit. Okay? Well, nothing keeps Amish from going and casting 1,000,000 1 Satoshi votes from his own account. Correct? So we really want to have this single system. Ideally, we might say we want to have a single system, whatever that means, where whenever somebody uses that system for voting, the vote starts with the correct source wallet and goes to the correct destination wallet. And that's the only way a vote can be cast. Or at least that's the only way a vote would count. So again, we have the public record on the other side where we can parse the blockchain and we can look at it and say, okay, well, this came from the correct source wallet, so we're going to count it. But just because a vote came from the correct source wallet, does that mean it should count? Or could there have been corruption on that side of it where too many votes came from the correct source wallet?
Well, each transaction should only be 1 Satoshi large. So you can rule out anything that's larger than that in a single transaction.
Oh, sure. But somebody who's trying to corrupt it would probably not make ones larger than that. They would just make lots of ones that size. Right? Go ahead.
Instead of counting all votes as the same source, you can, before the voting, distribute just 1 Satoshi for everyone who's allowed to vote.
Okay.
So that way, everyone just will have 1 coin and you can just count these transactions.
Okay. So so everybody has a coin. So now we have a fixed number of external votes, right? Okay, so we have our fixed number of external votes. Everybody's got their Satoshi. If they choose not to vote, they can pocket the Satoshi. Fair enough, fine. Today's market value, that's a couple bucks, something like that. We spend more than that on voting, so it's not today, so it's not going to be a big deal. Okay, so we're going to distribute that. So what I want you to think about for next time, everybody who's supposed to vote now has a Satoshi. How do we still make sure that only those Satoshis showed up? Let's say only 50% of the population who was allowed to vote votes, but we have 75% voter turnout from a Satoshi voting perspective. Nothing necessarily has guaranteed that the Satoshi that showed up for the vote was one of the Satoshis we distributed. But I think we're on the right track here where we're thinking about the source. Where do those come from? Do we have a single source, or do we have 1 source per voter? And we have some sort of way of uniquely identifying them. All right, I'll see everybody on Wednesday.